Hi everyone, Tina here, and today I'd like to talk about combining graph transformations. I have made two other videos which I'd recommend you watch before this one if you haven't already. One is on graph transformations in general, and the other one is on graph transformations involving the modulus function. In this video, we'll focus on the order in which you should do graph transformations if there's more than one involved, and we'll go through some examples. Here is the order in which you should do graph transformations. First, you start with any horizontal transformations inside the brackets in this specific order. Translations come first. So in this case, anything here where the plus b is, you should do that first. Then any horizontal reflections, then any horizontal stretches. After you've dealt with the horizontal transformations, you move on to the vertical ones. So we're looking outside the brackets this time. And in this order, we want to do reflections first, then any vertical stretches, and finally any vertical translations. An important thing to note here is that horizontally, translations come before any reflections or stretches, whereas vertically, translations come after any reflections or stretches. Now we've seen the order, let's take a look at some examples. Example 1, we've got a diagram showing a sketch of a graph y equals f of x. The curve passes through the origin, the point A, 2, -1, and the point B, 6, 4. And then we've got 4 parts to the question, all with different transformations here. Let's start with part A, y equals 2 f of x minus 1. If we refer to our checklist in terms of the order, we haven't got any horizontal translations, we haven't got any horizontal reflections, and we haven't got any horizontal stretches. So there's no horizontal transformations here. The x is on its own inside the bracket. In terms of the vertical transformations, we haven't got a reflection because there's no minus on the outside, but we do have a stretch of scale factor 2. So that is the first thing we should deal with. If we think about what that would do on the graph, it would stretch in the y direction by a scale factor of 2, so something like this. The new points would be the origin still, so nothing's changed there. This one would be 2 minus 2 now, and this one up here would be 6, 8. So the y's have been multiplied by 2. We've dealt with the stretch. We also have a vertical translation because the -1 on the end tells us that we want to move the entire graph down 1. So if we put that on our final answer, it's going to look something like this. So the origin has moved down to 0, -1. That minimum point has also moved down 1 to 2, -3. And the top maximum point has also moved down to 6, 7. We've dealt with the translation and that part is done. Part B, y equals f x plus 2 plus 2. So first things first, check for any horizontal transformations. And in this case, we do have a horizontal translation. Plus 2 inside the brackets means we want to move the graph left 2. So if we do that first up here and see how the points have changed so far. So the origin is going to move left 2, so we'll have -2, 0. This point here also left 2, so 0, -1. And this point up here, 4, 4. Moving down the list, there are no horizontal reflections or stretches. Vertically, there's no reflection or stretch, but we do have a vertical translation again. This time, +2 on the outside means we want to move up by 2. So again, if we do that on the final version, it will end up looking something like this. So the point which was -2, 0 will now be -2, 2. This point will be 0, 1, and that point up there will be 4, 6. Part C, y equals 1/4 f of 2x. No horizontal translations or reflections, but we do have a horizontal stretch. 2 inside the bracket means we're actually going to squash the graph by a scale factor of 2, or in other words, multiply it by a scale factor of 1/2. So let's do that up here. Again, origin isn't affected because 0 divided by 2 is still 0. This point is now 1 -1. It's been squashed. And similarly, this point up here is now 3, 4. That deals with the horizontal stretch. No vertical reflection, but we do have a vertical stretch. The quarter means we want to squash the graph this way by a scale factor of 4, or times by 1/4. If we imagine squashing that graph and then put the result on the final answer, it's going to look something like this. So again, origin unchanged. This is now 1 minus 1/4, and this one is now 3, 1. That deals with the vertical stretch, and there's nothing else to do, so we're done. Last part of this question, D, y equals minus f of x minus 1. We do have a horizontal translation. -1 inside the bracket means we want to move to the right by 1. So let's do that first. Note how the points have changed. So 1, 0 for the origin, 3, -1 for this one, and 7, 4 for that one. That deals with that. No reflections or stretches in the x direction. We do have a reflection in the vertical transformations. So we actually want to reflect this time in the x-axis. Thinking about what that would look like down here, something like this. This point stays as 1, 0. This point becomes 3, 1, and this point becomes 7, -4. So we've dealt with that, and there's nothing else to do for this one. Example 2. Given the function t of x equals 3 modulus of x minus 1 take away 2, where x is a real number, part A, sketch the graph of the function, and part B, state the range of the function. Now, when the modulus function is involved, it's a good idea to start with a basic sketch of the modulus of x in this case, and then see what happens in terms of transformations. So if we use this space up here, the modulus of x, as it is, would look something like this. So this is y equals the modulus of x on its own. This is the original function, which has then been transformed in various ways. So we can now use the checklist and figure out what's happened. We do have a horizontal translation here. -1 inside the modulus means we want to move the graph 1 to the right. So that step would cause the graph to move 1 to the right. And that's y equals x minus 1 all inside the modulus. So that deals with that. We don't have any horizontal reflections or stretches. If we then move down here, we don't have any vertical reflections either. We do, however, have a vertical stretch with the 3. So that's going to cause the graph to stretch in the y direction by a scale factor of 3. And then finally, we do have a vertical translation. So the -2 on the end means we want to move that green graph down by 2. We can do that on our answer down here. So if we think about that, it would look something like this. So that deals with the vertical translation. But on its own, that graph doesn't really tell us much, so we should work out what this point here is. Going back to the original sketches up here, that minimum point started off at the origin, but as soon as we moved it right by 1 in that first step, we made it so that the minimum point was 1, 0. The vertical stretch in the green step didn't change that, but when we moved the entire graph down by 2, it means that that point now is going to be 1 minus 2. That is good for part A. T of x equals 3, x minus 1 minus 2. For part B, they want us to state the range of the function. So remember, range means all of the output values, or y values in this case. So if we have a look, the y values or output values can never go below this point, and that is where y equals -2. So the answer for the range would be that our function t of x always has to be greater than or equal to -2. Last example, the point with coordinates -3, -5 is a stationary point on the graph with equation y equals h of x. Determine the coordinates of the stationary point on graphs with the following equations. And then we've got various different graphs there. In this example, we're not given a sketch of the function, just the coordinates of the stationary point. So we can think this through, just thinking step by step what's going to happen to the coordinates at each step. So let's start with part I. We've got y equals h, 2 of x minus 5, and all of that is within the modulus. If we start with -3, -5, and then use our checklist to help, so no horizontal translations, no horizontal reflections. We do have a horizontal stretch, so that 2, again, is going to squash the graph by a scale factor of 2 horizontally. So that means the coordinates are going to become -3/2 -5. And that deals with that. No vertical reflection or stretching. We do have a vertical translation though. So we want to move down by 5, means the point is going to go down by 5, -3/2 -10, which deals with that. And then finally, the modulus, the fact that it's around the entire expression means we're not going to have any negative outputs allowed. So that final point is going to be -3/2 +10. So just to reiterate, the modulus symbol means that any output has to be positive. Let's look at the next part. So this time y equals h and then quarter x plus 1. Thinking about what's going to happen to -3, -5, we do have a horizontal translation. +1 inside the brackets means we want to go left 1. So if we do that, we'll end up at -4, -5, and that deals with that. No reflection horizontally. We do have a horizontal stretch. A quarter means we're going to get 4 times times as large in the x direction, so minus 16 minus 5. And then that's it. In this case, there are no vertical transformations or transformations happening outside the brackets. So final answer is minus 16 minus 5. Last one, y equals 2 minus a fifth h of a half x. So lots going on with this one. Again, let's start at minus 3 minus 5. No horizontal translations or reflections. We do have a horizontal stretch. That half means we're going to stretch by a scale factor of 2 in this direction. So let's do that first. Minus 6 minus 5. Vertically, we do have a reflection this time with that minus on the outside. So that will be minus 6 positive 5. We also have a stretch vertically, scale factor of fifth, minus 6, 1. And finally, there is also a vertical translation with that plus 2 on the end. So we want to move the stationary point up by 2, means our final answer will be minus 6, 3. That deals with that, and we're done. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else that you think might find it helpful. Thanks and see you next time.